Welcome again then to the DS Incubator. This is the series about relational data, and today is the last chapter. We're going to be talking about the case when the data does not necessarily live in your computer as data sets, say saved in CSV files or in some other form, but instead when they live in what is called a relational database management system. You may hear me say RDBMS for short. So that is the case, for example, of the MySQL databases or Postgres databases, something that generally is hosted in someone else's computer in a remote server, and you access that server in some way, and then you get data. Sometimes the computations also happen on the server, so that means that you can work with data that wouldn't otherwise fit necessarily in your memory, in the memory of your computer. So that's a pretty common case, so I didn't want to finish the series without acknowledging that what we have seen so far is a relatively simple version of what happens in the wild, and more commonly, when we talk about databases, we talk about this thing, when the relational data lives in a management system. I'm going to be cheating a little bit today. I'm going to be working with a flavor of an SQL database that fits actually in a file and fits in my computer, in the memory of my computer. So I'm going to be storing this database management system in a file, an SQLite file. So the objectives of today are going to be to connect to such a file, to such a relational database management system. Also, to copy data that we have in a data model that we create with a DM package, how to reuse the knowledge that we capture in that data model and kind of how to pass it, how to copy it to that relational database management system. Then we're going to be using that RDBMS in two ways, in a simpler way with dplyr and in a more complex way with the DM package, basically doing just a tiny bit of what we have already done in meetup number 1 and 2 of this series, just to show you that these two packages work as well with data that lives in your computer as well as with data that lives in such a relational database management system. So let's jump to that. I'm going to be working with, so the series is hosted here, the chapter is hosted here in the folder number 4, so that would take you to today's notes that look like this. Although I'm going to be working here in our studio directly to show you the source code that leaves behind. So we're going to be using with these two packages that are the ones that allow us to connect to a relational database management system. The DBI package is always necessary to connect to these kinds of databases, and the RSQLite package in particular I'm using because the flavor of a database management system that I'm using is SQLite. That is called a driver, so depending on the kind of database that you use, you will need a different type of driver. So today is just RSQLite. Then I'm going to be showing how to copy data data model that we created with the DM package to an RDBMS. So we need the DM package, of course, and then I'm going to be showing how to use it also with DM and with dplyr. So we need dplyr as well. And finally, I'm going to be using the here package simply because it's convenient to me. All right. So let's get to the point of once we have an RDBMS, how can we copy to it some data that we have structured locally. So the connection goes something like this. In particular, for the driver that I'm using, actually, sorry, I didn't run this chunk where I attach all the packages that I need. So I'm going to go back to that. And now here. So the database I'm going to be storing in this file with an extension SQLite. That is the driver where we're going to be storing the database. That is going to be our relational database management system. Now I want to connect to it. I still have no data, but I still want to create a connection to it. So what I do is, this call is pretty complex, at least to my eyes. And the reason is because if you do dbi db connect, if you ask for help for the DB, something went wrong here, DBI, DB connect, oh, there you go. So the help file, I find it, documentation function is missing. Let's see if I have it here already. All right, the point I wanted to make is that the arguments that you need to pass to the function DB connect are not necessarily documented in that function itself. They depend on the driver, which in this case is RSQLite. So you have to read the documentation of RSQLite, of SQLite function to learn which arguments you pass here. So the RSQLite package has this function as SQLite function, and it needs this database name, DB name argument. So that is simply the path to the file that is going to store the RDBMS. Okay, so with that we have a connection, and a connection looks something like this. It's simply a little bit of metadata, and for this particular driver, for the SQLite version, it points, it shows you the path, and that's about all that we need to know. So say that we already have an RDBMS, and say that we already have a database model that we created with the DM package. So the tables that I'm creating here are the ones that you already know from earlier in this series. The companies table, which has a little bit of information for 2 companies, the ID of the companies and some information about them. And then the categories table, just 2 tables, which have basically for each ID, for each company has information about which business sector they work on, right? So those are the tables that we have. And we learned last time, or a few meetups ago, how to create what's called a database model or data model. So a DM with a DM package. So this object stores the tables, and it can store more information. For example, which are the primary keys of those tables, which are the foreign keys of those tables. So the DM package, it was pretty cool to learn how we could structure our data model very formally. And it would be nice to reuse that knowledge and to be able to, if we want to start using later down the path, we wanted to start using a remote database. Okay, how can we copy the data model that we have locally in our computer to the remote database? And the DM package makes it very easy with the function copy DM2. So it defaults to creating temporary tables, which means that you have to use temporary equals false if you want to create a permanent table, a permanent data model. And it takes 2 arguments: the connection that we already created above. We already tell DM where, in which kind of remote RDBMS we want to store the data model, and then of course it takes the data model itself, right? So that's how you simply copy in one call the data model from your computer to the database management system. And if that's all you need to do, at some point, you want to populate the remote database with the data that you have locally. So that's all I needed to do. Then I just close the connection. It is best practice to do that every time you work with a connection. Then, when you're done, you call the function DBI disconnect, and that connection will no longer be available. So that's how you do it. So now we already have an RDBMS, and say that someone else or you at some other time want to use the data that lives inside that RDBMS. Okay, in this case, I'm gonna be using, as I said before, the SQLite version. So I need a file to point to the file that stores it. So the database is living here in this database file. And now we connect to it. So in the same way that we did before, we create this connection object that points to that database file. So that's how we are doing here. And now let's use that connection in 2 ways, with dplyr and with the DM package. So with dplyr, first, the one thing you might want to do is to see which tables exist in that connection. So this is a function that comes from the most lower level package that deals with connections, the DBI package. So this function DB list tables tells you that, okay, we have the table categories and the table companies, right? Which makes sense. So now, usually if you work with dplyr, you can get a table, say companies, from this connection with the tbl function. So typically you would copy that table to an object if that fits in memory, and there it is. The same we're going to be doing with the categories table. So now what we have simply is two data frames. One is called companies, the other one is called categories, and then you would use dplyr as you would normally do. So for example, I would be using the dplyr package here to join companies with categories by the column companies ID, which is a shared column between the two databases, the two data sets. And that works fine, and we have the data that we expected. It's simply a spreadsheet with which has all the data that we need for an analysis. The one thing that dplyr doesn't tell you is what is that column that joins the two tables together. In this case, it's very simple. We have only two tables, and the name of the column is the same in the two tables, so you can quickly realize that that is the relationship between the two tables. But in the wild, usually it's not so easy, and that is why having a data model like the one that we create with the DM package is useful. So you don't need to know this relatively low-level detail of which is the columns that relate different tables together. So that's why I want to show how you would use the remote database or the RDBMS with the DM package as well. So typically, I'm gonna get inside the body of this function. This function is a helper that I'm gonna argue that if you're gonna be using data in a data model many times yourself, or because you're developing software for someone else is going to be using that particular database, it's kind of nice to create a helper that allows you, so that knows about the connection that you're going to give it. In this case, is the database for companies. So I created the helper companies DM, which already knows which tables that connection has, the companies and categories tables, and also here is where I add the more formal definitions of the relationships between tables. So I add the primary key for the table companies, which is companies ID, and I add also the foreign key for the categories table, which is also company ID pointing to companies, right? So this is kind of my the smallest version I could come up, the smallest example I could come up with to kind of show how if you maintain a database that people is going to access multiple times, it would be nice to create just a tiny helper that has all that schema that defines the relationship between the tables. So that helper could live in an internal package, or it could live in some R file somewhere. In this case, I just created it here on top. And now creating that DM object, so the data model for the company's database is simply this, right? So we just take that connection that we opened before, that's the metadata pointing to the file that has that SQLite database, and then we pass that connection to the company's DM function, which is our helper. So with that, if I print the DM object, what I get is the metadata for it. As you can see, it's already relatively nicely structured. It already has information about the primary key, has information about the foreign keys. And with the DM package, you may go back to meetup number 2, I believe. But one nice thing is that once you have defined data model in such a formal way, then you can use some convenient functions of the DM package itself to do things that would otherwise require knowledge of the internals of the table. So here, for example, I can just use the function flatten to table to create the same spreadsheet that before I created with dplyr. But before, I had to know that the relationship between the tables was by the column company's ID. In this particular case, I don't need that because that relationship is already defined in the data model. So the data model holds that metadata. And then, well, if that's all we need to do, we just disconnect from the collection with dbi db disconnect, and that's it. So this is an internal chunk of code for myself, but I wanted to show you that the files actually live here. So this file that I'm highlighting here, the database.sqli, is the database itself, is the database file, right? And that's bringing us to the end of what I wanted to show, with plenty of time for comments or questions if we want. So I'm going to go back to the meeting here. And we have Miria here. Hi, Miria. Any comment or question about this?
Thanks. No, I'm all good.
Great. Thanks very much, Mia, for joining me in this series. Today is the last one, and next time we're going to come up with something else. See you next time.